Okay, let us continue. So for now, we covered rotation matrices, angular velocity, homogeneous transformation matrices, and twists. So here you can see the drawing for the H. So pretty much the same. We can change the twists. Here, so here a lot of derivation for the twists. It's like the idea. Let me just give you the idea. For example, from here we can derive H and B. This is equal to H BA HAB. From here we can derive, for example, HAB with a dot. BA. What should I write? It will be twist BA H. What indices should I write? It's like I need to multiply it with the inverse. It's mean BA, the right side and the left side. So here will be HAB, BA. I would like to avoid misleading. So we can put it right here, and this twist will be H times twist, another twist with another representation, times H inverse. So it is exactly what you can see right here. So, or another way around, H inverse twist and H. We can write all the matrices. We can do the derivation. So there's just a lot of going on here. You can take a look at this later with your own pace. But if we'll do the calculation, we'll find out this equation. And right here you can see if you have a motion of a body K that moves around another body with L, you can express it with another frame J. So here you can see the motion of body K that moves around L, and the motion is represented in the frame I. And you can express this motion in some another frame J if you multiply this with this homogeneous transformation matrices. So on the right it could be, for example, T I K. Here we can write something like I something else. Like J. And this is the way how can we express this twist in the third frame. It's like we can express how this markers moves around, for example, my laptop, and the motion could be expressed in the absolute world frame. Or we can take any other 3 random frames. So the important point here, look, let me repeat. Let's assume that we have body with the frame K. For example, this marker is the body with the frame K. And it moves in respect, for example, my laptop. L will be my laptop. So in this case, we have twist of the, let me put it like marker around laptop, and we can express this motion, for example, let's assume that we have just H and we want to compute it in the in the L. Let's start with that. Yes, sure. In this case, it will be just L, M. Where should I put a dot? The first, right here. So it's pretty obvious. Okay. Now we can do the following. L, M. If you multiply it with the two H's, here it will be L, here it will be L. What is your name? Yazan. So let's assume that we create another frame, U frame. I will put Y. It is U frame. So Y for the Yazan. And it will be a twist of the same marker. The motion is expressed in the same frame of my laptop, but now it's expressed in your frame, in matrix form. It is great. It was in matrix form because it's 4 by 4, 4 by 4, 4 by 4. We can rewrite it in the vector form, so also I'm not going to go in the details, but if you'll do this, so it's pretty obvious, it's just linear algebra, you will be left with this nice equation. So it's like the same idea that you have initially KL in the I frame, and on the left the same KL but in the J frame. And in order to go from one frame to another frame, we use this adjoint. It's just a very easy matrix to compute. Okay. So this adjoint will be, look, 9 by 9 matrix. Oh, yeah, 6 by 6, because R in R, you see? 6 by 6. Twist in the vector form is just a column with the 6 entities, and you can multiply it. So this is the way how can we compute adjoint.